It is quite remarkable to think about the secrets hidden in the deep. Down on the cold, dark seabed of the North Atlantic, there are creatures that can live for an astonishingly long time. One of these is the humble Quahog clam. Imagine a living being that was born before many of the great historical events we read about in books. In 2006, scientists found a Quahog clam that was 507 years old. This incredible creature, nicknamed Ming, was alive when Leonardo da Vinci was painting, and before William Shakespeare had even been born. It is a true Methuselah of the sea, a silent witness to centuries of change. These clams are not just fascinating because of their age. They are also invaluable storytellers. They spend their entire lives in one spot, quietly filtering food from the water. As they grow, they build their shells layer by layer, a little bit each year. This process creates growth rings, very much like the rings you see inside a tree trunk. Each ring holds chemical clues about the ocean environment during that specific year. It records the temperature of the water and the types of nutrients that were present. They are, in essence, tiny, natural archives of the ocean's past, preserving a detailed history that stretches back for hundreds of years. Think of it as a diary, written by the ocean itself. While a single clam tells the story of its own lifetime, scientists can find many clams, both living and ancient shells. By carefully studying the shells of clams that lived at different times, they can piece together a continuous timeline of the ocean's history. This allows them to see how the ocean has changed, not just over a few years, but over many centuries. This long-term perspective is crucial. It helps us understand the natural rhythms of our planet and allows us to see if the changes happening today are part of a normal cycle or something entirely new and concerning. The discovery of these ancient clams has opened a new window into our planet's past. Before, our knowledge of past ocean conditions was limited. We had records from ships and more modern instruments, but these only went back a relatively short time. The Quahog clams provide a much deeper history. They offer a direct record, written in the very chemistry of their shells. It is a testament to the wonders of the natural world, where even a simple shellfish can hold the key to understanding vast and complex systems that affect us all. These quiet inhabitants of the deep have a very important story to tell us. So, how do scientists read this remarkable ocean diary? The process is a wonderful mix of careful observation and advanced science. First, they collect the clam shells from the ocean floor. They then slice the shell in half, revealing the beautiful fine lines that mark each year of growth. Just like with a tree, they can count these rings to determine the clam's exact age. This allows them to assign a specific year to each and every layer of the shell. It is a meticulous process, requiring great patience and precision. Each tiny ring represents a chapter in the ocean's long and complex story. Once the rings are dated, the real detective work begins. Scientists use tiny drills, almost like a dentist's tool, to carefully take a small powder sample from each individual growth ring. This powder contains the chemical information from that year. They are particularly interested in certain types of atoms called isotopes. The ratio of different oxygen isotopes in a shell layer, for example, can tell them the exact temperature of the seawater when that layer was formed. It is an incredibly clever way to take the ocean's temperature from hundreds of years ago, long before the first thermometer was ever dipped into the sea. By analyzing the chemistry of ring after ring, scientists can build a year-by-year record of ocean conditions. They can see when the water was warmer or colder. They can also study other elements within the shell to learn about the food sources available to the clam. This tells them about the types of tiny floating plants, or phytoplankton, that were present in the water. Putting all this information together from many different clams gives them a detailed picture of how the ocean currents and the entire marine ecosystem have behaved over a very, very long time. It is like watching a slow-motion film of the ocean's past 5 centuries. This method gives us a powerful baseline. It shows us what the ocean was like before the widespread industrial activity of the last 150 years. By comparing the past with the present, we can clearly see the impact that human activity is having. The clamshells show that the changes we are witnessing now are happening at a speed and scale that is unprecedented in the last 500 years. This long-term view, provided by these humble clams, is essential for understanding the challenges our oceans are facing today. They are not just old shells, they are vital pieces of evidence in the story of our changing planet. The information from the clams is particularly important for understanding something called ocean currents. Imagine giant rivers flowing within the ocean, some on the surface and some in the deep. These currents are constantly moving vast amounts of water all around the globe. One of the most important of these systems is in the Atlantic Ocean, often called the Atlantic Meridional Overturning Circulation, or AMOC. It works like a giant conveyor belt. Warm, salty water flows north from the tropics near the surface, warming the air and giving places like Western Europe a much milder climate than they would otherwise have. It is a critical part of our planet's climate system. As this warm water travels north, it gets colder and some of it evaporates, leaving the remaining water even saltier. In the North Atlantic, near Greenland and Iceland, this cold, salty water becomes very dense. Because it is so dense, it sinks deep into the ocean. From there, it begins a slow journey back south in the deep ocean, eventually rising to the surface elsewhere and starting the cycle all over again. This constant overturning, this sinking and rising, is what drives the entire conveyor belt. It distributes heat around the planet, just as our own circulatory system distributes heat around our bodies, and it plays a huge role in regulating global weather patterns. The strength of this conveyor belt is not always the same. The clamshells have shown scientists that the AMOC has had periods of strength and weakness in the past. These natural fluctuations are a normal part of its behavior. However, the data from the clams, combined with modern measurements, suggests that the AMOC is currently weaker than it has been at any point in the last 1,000 years. This is a significant finding. Scientists believe this weakening is being caused by the melting of glaciers and ice sheets, particularly in Greenland. This melting is adding a huge amount of fresh, less dense water into the North Atlantic. This influx of fresh water is a problem because it disrupts the sinking process. Fresh water is not as dense as salty water, so it does not sink as easily. If too much fresh water is added to the surface of the North Atlantic, it can effectively block the engine of the conveyor belt. It dilutes the salty water, making it lighter and preventing it from sinking into the deep. This slows down the entire circulation system. The AMOC is a delicate balance of temperature and saltiness, and we are now changing that balance at an alarming rate. The weakening of this vital planetary system is a clear warning sign. Scientists are concerned that this continued weakening could push the AMOC towards a tipping point. A tipping point is a threshold where a small change can trigger a sudden and dramatic shift in an entire system. Imagine leaning back in a chair. You can lean a certain amount and still be stable, but if you lean just a little too far, you suddenly tip over completely. The AMOC could be approaching a similar point. If it weakens beyond a certain threshold, it might not just slow down further, it could shut down altogether, and this change could happen very quickly, perhaps in just a few decades. The clamshells show that the system has shown signs of instability before, but never under the pressures it faces today. If the AMOC were to collapse, the consequences for the global climate would be profound. Without the warm current flowing north, regions like the United Kingdom and Scandinavia could experience much colder winters, with temperatures dropping by several degrees. At the same time, the heat that is no longer being transported north would build up in the tropics, making those regions even hotter. Rainfall patterns would shift dramatically around the world, potentially affecting agriculture and water supplies for billions of people. It would also lead to more rapid sea level rise along the east coast of North America and disrupt marine ecosystems that depend on the currents. It would be a major reorganization of the climate we depend on. This may sound alarming, but it is not a prediction of something that is certain to happen. It is a warning about a possible future if we continue on our current path. The primary driver of the ice melt that threatens the AMOC is the warming of our planet, which is caused by the increase of greenhouse gases in our atmosphere from burning fossil fuels. Therefore, the most effective solution is to reduce these emissions. By transitioning to clean energy sources like solar and wind power, protecting our forests, and adopting more sustainable ways of living, we can slow down the warming and reduce the amount of fresh water melting into the North Atlantic. There is still time to act, and there is reason for hope. The Earth's systems are resilient, but they are under immense pressure. The ancient Quahog Clams have given us an extraordinary gift. They have provided us with a clear and undeniable warning, written over centuries in their very being. By heeding this warning and working together to reduce our impact on the planet, we can help to stabilize this vital ocean current and protect the climate for future generations. The future is not yet written, and the choices we make now will determine which path we take. It is a responsibility we all share.